We go on with our fourth and last presentation for today, which will be coming from Paulo POSSA from inVision, and he will talk about line scan applications made simple. So I can see you. Hopefully I can hear you too, Paulo.
Yeah. Can you hear me?
I can hear you, and your presentation is still in presentation mode. So please start.
Okay. Thanks, Peter. Hi, everyone. I'm Paulo POSSA, Product Manager at inVision. As we all know, precise timing is critical in line scan applications, but getting the perfect synchronization between cameras and external devices can be a real challenge. So today I'm going to walk you through some key functions that will help you to tackle these challenges. Okay, and here is what we will cover today. First, I will give you a quick overview of the frame grabbers in our portfolio. Then I will dive into the onboard GPIOs and synchronization tools that are key for high performance and high precision line scan applications. After that, I will show you some DMA processing functions that let you rearrange data in the application buffer without charging the CPU. I will also introduce some software tools that make system development easier. And finally, I will wrap up with a quick summary. So let's start with an overview of our frame grabbers. So these are the well-known frame grabbers from Euresys, which is now part of inVision. We have a complete series of frame grabbers covering both camera link and co-express. For camera link, we have the GrabLink family, ranging from base up to full DECA configurations. For co-express, we have the CoaxLink family, supporting 4 and 8 6x6 connections, as well as 1, 2, 4, and very soon 8 6p12 connections. We also support co-express over fiber for 40G and 100G cameras. Okay, so now let's look on the onboard GPIOs and synchronization tools available in these grabbers. Our frame grabbers come packed with a rich set of inputs and outputs, compatible with a wide range of sensors and motion encoders. You can access them via 2 internal connectors and 1 external connector. We provide an extensive toolbox of embedded features to handle those I/O signals, things like quadrature decoders, delay tools, dividers, and rate converters. We also have the C2C link interface for syncing multiple boards and an I/O extension if you need to extend the number of I/Os. Let's look at a practical example of how this works in a high-performance line scan setup. So let's take a simple system with 1 camera, 1 light source, and a motion encoder. The encoder connects to the frame grabber via high-speed differential inputs, sending pulses that correspond to the conveyor's movement. We then use embedded quadrature decoders and rate converter to create the events that drive both camera trigger and light strobes. The camera and illumination controller defines the strobe duration for the light source and exposure time for the co-express triggering, which includes jitter compensation to clean up any transmission jitter. The key takeaway here is that the entire control loop, conveyor movement, light strobe, and camera trigger, happens inside of the frame grabber's FPGA. There is no host PC interference, which means 0 latency and 0 jitter. Plus, you can sync multiple frame grabbers together using C2C link. Inside of the camera and illumination controller, there is a feature called multiple cycle timing. This allows you to create a sequence of camera cycles where each cycle has its own specific exposure time, strobe delay, and strobe duration. Plus, you can also map each strobe in that sequence to a different IO pin. This allows you to drive different light sources in each cycle. So here is an example of that in action. With this mechanism, we control 3 light sources with different wavelengths activated alternatively for each line to be acquired. The result is that you get 3 different images highlighting different effects, all in a single scan. We are also using the same mechanism for 3D surface inspection based on photometric stereo with 1 line scan camera and 4 light sources. So now let's take a look at a series of powerful functions that provide flexible data arrangements in the application buffer, all without CPU intervention. The first feature is DMA ROI. Inline scan applications define a region of interest, usually means manipulating the image in the application buffer, which is time consuming. With DMA ROI, we optimize memory usage and boost performance because the application buffer will only contain the useful data. The second feature is DMA stitching. This allows you to scale up the field of view by using multiple line scan cameras. This is especially important for large printing and foil inspection. With our driver, you can automatically stitch images from different cameras directly into the application buffer with 0 copy. It's completely transparent to the application, which just sees the assembly of cameras as a single image producer. Then there is DMA interlacing. This is useful when each line exposed to alternating light sources. Normally, processing this requires memory copies and on the host PC, which takes time and CPU resources. We've moved this process to the DMA level, so no memory copies and no CPU processing are necessary. Your application simply receives 2 separate buffers, 1 for each light source. And here's a demo of this function for the secondary battery industry, where we are inspecting battery foil using interleaved dark field and bright field illumination. The camera acquires 1 line with dark field lighting and 1 line with bright field, and so on. The Quaxlink card then separate these lines and store them into 2 distinct images in the host memory. Now let's talk about our software tools and how they simplify line scan design. Let's start with eGrabber Studio and our SDK scripting capabilities. eGrabber Studio is a powerful tool for evaluating components and testing different parameters of your system. The eGrabber GenAPI script allows you to automatically configure a system based on predefined parameters with no need to recompile your software application. You can easily write these scripts manually or directly generate them in eGrabber Studio once you validate your configuration. Next is Memento. Memento provides accurate timestamp logging events related to camera, frame grabber, driver, and software application. It includes a logic analyzer feature to help you dig into specific system events. And most importantly, it's not intrusive, requiring very, very low CPU usage. Last but not least, we have metadata insertion. Basically, each line trigger latches metadata. So each line triggers will capture metadata coming from the system. This information is attached to the resulting line. This adds an extra dimension to your application by telling you the exact conditions under which the line was acquired. It's great for precise image reconstruction, ensuring that each line corresponds to the right physical position. Also, to maintain data integrity and monitoring performance. So let's wrap up with a quick recap of what makes our frame grabbers stand out in high-performance line scan applications. First, we've got feature-rich digital I/Os and I/O toolbox. This gives you the flexibility to connect directly to encoders, sensors, and lighting controllers, and even sync up multiple frame grabbers seamlessly. Second, we offer precise camera and illumination control. With hardware-based triggering and nanosecond level precision, you get near instantaneous reaction to external events. This ensures that your exposure and illumination are tightly synchronized on every single line. Third, we have flexible DMA data arrangements. By handling tasks like ROI, stitching, and interleaving at the DMA level, we optimize our memory usage and boost processing performance, all with zero copy and no CPU overhead. Fourth, we make configuration and debugging easy. You can use GenAPI scripts for quick system setups and updates, and rely on Memento to visualize the interactions between your camera, grabber, driver, and software without slowing down things. And finally, we have metadata insertion. By attaching precisely synchronized metadata to each line, you gain that extra dimension of insight, knowing exactly the conditions under which every single line was acquired. That's it. Thank you for your time.
Thank you for your presentation. And as we have already some questions, I think I will start immediately with the first question. On the Coax Express 12 grabbers, there were data forwarding grabbers, but it looks like Coax Express over fiber does no longer have the data forwarding option. Why?
The answer is this is coming. Yeah, this is coming. Yeah.
Maybe we should have a closer look at the Vision Fair at your booth.
Yeah, exactly. Yeah.
And is the CXP12 to COF converter comparable to a frame grabber from technology and pricing side, or is it more like a low-cost passive element?
In terms of price, it's comparable with frame grabber, because it's a FPGA based product. So we have to really take the high speed interface from the coax press side, so the coax shell side, and then transformed it into the fiber side. So we have to have all the high speed transceivers and a little bit of processing inside. But so it's not a passive component. It's a very active component.